Reflections part 2. So I want to do some reflections of just a single point and then look at what is happening to the coordinates. So on all of these, I have point A is at -1, comma 2. If I first reflect it over the x-axis, it is 1, 2 away, so its reflection must be 1, 2 away. So it is going to be right here at -1, comma -2. If I reflect it over the y-axis, it is 1 away from the y-axis, so its reflection must also be 1 away from the y-axis, and that's at the coordinate 1, comma 2. So if we look at what happened for both of those coordinates, on the reflecting over the x-axis, the x-coordinate did not change. It is still exactly the same thing. However, the y-coordinate went from a +2 to a -2. On the reflecting over the y-axis, the y-coordinate stayed the same, but the x-coordinate went from -1 to +1. So this will be a rule, and I'll show you that in just a little bit. So if we were to reflect it over a line, so we're going to reflect over two specific lines, y equals x and y equals -x. Now the way this works is you need to go straight from your point to the line. So you're making essentially a perpendicular line. Now, if you look at what I went across, I went a diagonal of one box and half a diagonal of another. So if I do a reflection that's exactly the same thing, there's half of that diagonal and one full diagonal. Now this is A prime. These coordinates are 2, -1. Well, if you look at what happened, -1 went to the second part of our coordinate, and 2 went to the beginning of our coordinate. So what happened is we just kind of switched where their places were. We switched the x and y coordinates. Let's see if something similar happens to this one. So if I were to reflect this over the line and I go straight there, it's half of a box. So half of a box on the other side would be right here, A prime. And the coordinates of these are -2, 1. Okay, let's see what happened. The -1 became positive and went second, and the 2 on the x-coordinate became negative and went first. So it looks like they switched places and then changed the signs. Now, one thing it is important to notice, and there's this comment right here. The line of reflection is the perpendicular bisector of the segment connecting a point to its image. So let's break this apart. First of all, a perpendicular bisector. That means it's got to cross at a 90-degree angle and it cuts it in half. It's a bisector. And it's a perpendicular bisector of the segments connecting a point to its image. So when I made this line right here from A to A prime, I needed it to be perpendicular because if something is in a mirror, it has to be right in front of you. Okay, that's like perpendicular. And the two segments from here to here are going to be the same length. So that's the bisector part. So again, on the other one, this is a perpendicular line and it bisects. So each segment is exactly the same. Now, to make things easier, instead of having to count how many partial boxes or what have you it is away from the line, here are the lovely rules. So we kind of discovered these when we were looking at reflecting a point. So if you reflect over the x-axis, you take your coordinates x, y, and just make the y coordinate negative. That's your only change. You have now reflected it over the x-axis. If you want to reflect a point over the y-axis, you take your coordinates x, y, and just make the x coordinate negative. If you want to reflect over over the line y equals x, remember that is a positive slope of 1. You take your coordinates x, y, and you change them to y, x. What this means is you change the order. You flip it around. And if you reflect it over the line y equals -x, so that's a negative slope, not only do you flip the coordinates over, putting the y one first and the x second, you also change their signs. So let's practice this. So for I have 3 points, A, B, and C. If I want to reflect it over the x-axis, all I have to do is change the sign of the y-coordinate. So I'm going to leave the x-coordinate alone, and I'm going to change the 3 to a -3. For b prime, I'm going to leave the -2 alone, and I'm going to change the 4 to a -4. And for c prime, I'm going to leave the -8 alone, and I'm going to change the 0 to a 0, because -0 is just 0. So that was our rule. X comma y becomes x comma -y. Now if I were to take those same coordinates of a, b, and c, and I were to reflect it over the y-axis, then x comma y is going to become -x comma y. So now what I'm going to do is change the sign of the x coordinate, so like 1 becomes -1, and I'm going to leave the y coordinate alone. I'm not using your previous ones here. I'm always using the original a, b, and c, okay, just to let you know where they're coming from. If I were to take my original ones and reflect it over the y-axis, b prime would become +2, 4, and c prime would become +8, 0. So I'm changing the sign of the x coordinate and leaving the y alone. Now for the line y equals x, all I have to do is change their order. So x comma y becomes y comma x. So if I look at my original points, a prime is going to become 3, 1. So I change 1, 3 to 3, 1. B prime would be 4, -2. Flip those around. And C prime would become 0, -8. Now for the last one, y equals -x, not only am I going to flip everything around, but I'm also going to change all of the signs. So a prime becomes -3, -1. So I flip the 1, 3 and change both of their signs. B prime is going to become a -4, a +2. So I flipped it and then changed the signs. And C prime is going to become 0, +8. So you can use these rules instead of having to decide how far apart something is on a graph.